Hello. Welcome to this live stream, or if you're watching this after the fact, then welcome to this video. In this live stream, I'm going to be going over a bunch of mixed questions. So mixed exam questions, and the idea of that is, maybe you pick up something that you didn't remember. Maybe you could, something that was, you hadn't recalled to revise that. So, like some little fact that you'd forgotten. Maybe you'll pick that up and you'll be more prepared for an exam or something like that, or for class. And also maybe I'll go for a question on a topic that you're not 100% confident on, and as we go through that question, you'll gain confidence on that topic. Hello Rahman and HA. So on the screen right now is a question sort of testing your understanding of what it means for an equation to have no solutions. Okay, so it says, well, it gives you these simultaneous equations. It says the system of equations above have no solutions if a and b are constants. What is the value of a over b? Yeah, thanks for joining in. Would love if you could go over some OCR questions on what topics would come up on 2022 Higher Paper 6, as this is the mock paper I have tomorrow. Tomorrow. Well, we will be going over general topics, and I would suggest these are general questions that could come up on any paper, but these are actually, this is more EdXL focused. So apologies, this is not OCR focused. But hopefully it's still helpful. Alright, so what does it mean for an equation to have no solutions? Well, let's just think about an example. I want to make my pen a little bit thicker. Let's just think of an example like x equals x plus 1. Okay, this has no real solutions. Yes. Yep, this is all non-calculator stuff we're doing in this video. I should have mentioned that. This will be all non-calculator revision, so good for an EdXL paper 1, for example. This will have no real solutions because we can't add 1 to a number and get that same number, right? What if I gave you two simultaneous equations like x plus y equals 3 and x plus y equals 4? This has no solutions because we can't add the same two numbers and get a different result. Okay, so if we look at these equations, 3/4 x take a half x, that should be a y, by the way. I'm not sure why that says x, sorry. Apologies for that. 3/4 x take a half y equals 12, and ax minus by equals 9. What can we do here such that these simultaneous equations have no solutions? Maybe if you're watching it live, you could suggest something in the chat. Yes, maths is maths, so it can be applied to pretty much all exam boards. Thank you. Good point. So what can we do to this equation? What could we give values for a and b such that this simultaneous equation has no solutions? Well, take some hints from the examples I gave you. We could say a will equal 3/4 and b equals negative a half. It's really that simple for this type of question. You just need to understand what this means when it says it has no solutions. So to find the value of a over b, by the way, there's a bonus point here if you know where this question comes from. So for a over b, we need to just be good with our fractions. So we need to know how to work this out. 3 over 4 over negative 1 over 2. Well, if we're dividing fractions, maybe you've heard of KFC. KFC, that's right. KFC, keep, flip, change. Actually, I'm forgetting what KFC stands for, so I'm not going to use that example. I haven't said that for a while. But in other words, when you're dividing fractions, you flip the second one and then you multiply. So we're going to do 3/4 multiplied by -2/1. So that's -6/4 or -3/2. Okay, so final answer there is -3/2. Or actually, it could be, it depends if that negative belongs to the b. You could also say b is +1/2. In that case, the answer is 3/2. And I'm going to suggest that we don't include the negative actually, because it's asking for a/b, and we would say there that b equals 1/2. Yes, apologies for that. So the correct answer there is 3/2. Not a great start here. I'm making a couple of errors that I'm not happy about, but there you go. That was a question testing your understanding of an equation having no solutions. All right, on to the next one. I found this question interesting. I think I saw it on Reddit, maybe. It says the first 4 terms of a quadratic sequence are 0, p, 16, and 33. Hello, Yusuf. Welcome. Find the possible values of p. Okay, so what do you know about a quadratic sequence that is going to be helpful here? What do you know about a quadratic sequence that's going to be helpful here? And again, feel free to shout out anything in the chat if at any time you feel like contributing or you have any questions at all. Okay, so the key thing you need to remember about a quadratic sequence to help you to solve this problem is that the second difference is always the same. Okay. So how does that help us here to solve for p? Well, let's write out our sequence down below, and at least let's make a start. Maybe we don't exactly know where we're going to get our solution from, but we could at least make a start by finding the first difference between these terms. Okay, what's the difference between 0 and p? That's p. What's the difference between 16 and p? Well, how do you find a difference? It's just the second thing subtract the first thing. So 16 take p. Then 33 to 16, that's 17. And now let's try to find the second difference. And maybe you can start to see where we could go with this. Okay, second difference. 16 take p, take p. 16 take 2p. Right? Get that? Negative p take p, negative 2p. 17 take 16 take p. And here I'm going to write the whole thing out because you need to be a little bit careful with your negatives. So that negative is going to distribute to both of those terms. We're taking that whole expression. So this is 17 take 16, which is 1, and then negative p, which is plus p. Okay, now what could we do? Remember, look at what we have so far, the second difference, 16 take 2p and 1 plus p, and that we know the second difference is always the same. What could my next step be here in order to solve for p? Exactly, 16 to 33 is the same as 0 to p. Well, not exactly the way you stated, but I think you've got the idea. We want to equate these two second differences. So we can say, because in a quadratic sequence the second difference is always the same, we can say 16 take 2p is equivalent to 1 plus p. This equation is going to allow us to solve for p. So then, well, you need to be confident with solving equations. And, well, you could subtract p from the left-hand side or add 2p to the right-hand side. Let's do that. So over on the right hand side, we'll have p plus 2p, right? Negative 2p, add that to the other side. That's 3p. 16 subtract 1 is 15. Therefore, 15 divided by 3 gives us p equals 5. Okay? Yes. Yeah, I understood what you meant now, HA. Thank you, well done. Okay, so hopefully these questions are helping you out so far. I'm wondering if anyone's busy revising for tomorrow morning. And if maybe you're dropping in, and hopefully that's helpful. Okay, on to the next one. Functions. Who loves functions? I think this is a topic well worth practicing. Even at the last minute, you can pick things up. You can pick up notation, maybe notation you've forgotten, and I think that's something you can take into an exam that's really helpful. Okay, so this question says, the functions f and g are such that f of x equals 3x squared plus 1 for x greater than 0, and g of x equals 4 over x squared for x greater than 0. Part A says, work out g of f of 1. This is a 2-mark question. Okay, this is from an Edexcel exam paper. What does this notation mean? G of f of 1? Well, basically what this means is we want to work out f of 1 and then plug that into g of x. Okay, so f of 1 is the input of g of x. Okay, so f of 1 is the first thing we want to work out. How do we work out f of 1? We plug in 1 for x. X is the input, so this is going to be 3 times 1 squared plus 1. So notice there, the x there, I've changed the x to a 1, as that is our input. Okay, that's 4. Okay, so f of 1 is 4. Yes. Awesome. HA is carrying the chat right now. If anyone else wants to help him out, that'd be great. I always love to hear from new people joining in. Everyone's welcome to chat. Everyone's welcome to ask a question. Don't feel at all stupid to ask a question or whatever. Yeah, just shout anything out. So we've got f of 1 of 4, and then g, we want to basically then find g of 4, right? That's the same thing. F of 1 equals 4, so g of f of 1 is the same as g of 4. Okay, so now we're going to plug in 4 into g of x. The input there is in the denominator, and we square that, so we're going to do 4 squared. Ayola, welcome. Yeah, feel free to shout out any questions you have. Anything at all. So 4 over 4 squared, or that's 4 over 16. That simplifies to 1/4. So your final answer there is 1/4. Oh, what was your first paper on? What subjects did you have today? Was that science? Or maybe you had a different exam board? You've got mocks in a month. Hopefully this is good prep. Okay, now on to the second part. This is the 4-mark part. You'd say this is probably the most difficult part of this question. Okay, the function h is such that h equals f of g to the -1. What does that mean? That means inverse. And we'll talk about how you find the inverse of a function. English language reset. Oh, and Dimitri had maths higher. Okay, so which exam board, if you don't mind me asking? So another exam board had their higher maths paper today. Okay, let's continue. So f of g means basically what we did here. Now you notice it's not written exactly the same. We don't have a number in there. We don't have f of g of x. But don't get confused by that. It's still a composite function. It's still f of g. So what we want to do with that f of g is we want to input g into f. Okay, so try not to get lost in the notation. Often, if you trust your intuition, the notation will be the same as you expect it to be. Okay. At Excel was today. You're confusing me now. I know there's an Excel exam tomorrow. Or maybe you're talking about your mocks. Okay, so we want to do f of g of x. This means taking this function for g. I'll just finish this off, then we can chat a little bit more. We take this function for g and input it into f. Okay, so where the x is, we're taking this whole thing, 4 over x squared, and putting it in there. So it's going to be 3 times 4 on x squared, all squared, plus 1. And now you can simplify this a little bit, but we'll still leave it as it is pretty much. So 4 squared is 16 over x to the 4 plus 1. And then we're going to run out of room. Actually, I need to be a little bit clever about how I use my space here. This is 3 times 16 is 48 over x to the 4 plus 1. And I'm going to leave it like that. I'm not going to combine that into one fraction. And you'll see why in a minute. So that's f of g. Now we want the inverse of that. You remember how to find the inverse of a function? Oh, mock paper. Okay, yeah, now I'm understanding. Okay. Well, if you don't do too well on the first paper, it's not the end of the world, right? You know, if you've got your calculator for the second two, you can really recover if you're confident with the calculator. Make sure you bring your calculator. Often you can recover a lot of marks that way. Okay, so now we're looking for the inverse. Remember how to do the inverse. If you're not sure how to do this, I have a video on this. You can go and cram that in, or you could stay right here and we can go through it. So this is our function we're working with, f of g. What we want to do is to say let y equal 48 over x to the power 4 plus 1. That's this function here. And then we want to rearrange this in terms of x. So the first step here is I'm going to say 48 over x to the 4 equals y take 1. So I've flipped this whole thing around, right? I've subtracted 1 from the left-hand side, and then I've flipped the sides around. Okay? I haven't done anything magical at all. I haven't done anything too complicated. Just be aware I've taken the right-hand side and moved that to the left-hand side. And I've subtracted 1. Okay? Now I can multiply by x to the 4 and divide by y take 1. I'm going to do two things in one step here. So then I can say x to the 4 equals 48 over y take 1. And then take the fourth root. So x equals the fourth root of 48 over y take 1. And the last step, I'm going to do this over here. Sorry for the slightly messy working. The final answer is going to be over here. Then you just replace the x with h of x. Okay? Don't get too confused by that step. Basically, you're now saying what was the input is now the output. What was the output is now the input. That's the whole point of an inverse function. So this is h of x. H of x equals the fourth root of 48 over x take 1. And that's your final answer there. Okay, so that's inverse functions. Hopefully that's a good reminder. Okay. I always mess up when there's really hard question. I don't know how to start the question. Yeah, that's a really well, that's a common issue. knowing how to start a problem is a skill, I think. It's a revision skill you can practice. And looks like Iceberry is giving some advice. So read it first and try to think of concepts related to it, and step by step use your knowledge and simplify on every step. Yeah. And there's often, so one strategy to think about is there are four ways to represent usually a mathematics question: graphically, algebraically, numerically, and I'm forgetting the fourth one. Graphically, numerically, algebraically, and yep, apologize, it's going out of my mind. But basically the point is there's different ways of representing a question. So you can think of maybe drawing a graph, drawing a picture, trying to make an equation algebraically, something like that. If you're struggling to start, think of how another way you can represent that problem. Okay, the next question here is a rearranging problem. Make x the subject of the formula. This is, I would say, often a subject that causes problems. I would say there hasn't really been a year where this type of topic has been done really well. So I stuck this problem in here. Make x the subject of the formula. Slightly more tricky one. But basically you need to be good at rearranging equations and knowing where you're going with this equation, if that makes sense. So for me, looking at it, I know I want to combine the x terms together, and I can see a strategy to get there. And even if you don't see a strategy straight away, maybe you see this fraction, or hopefully you see this fraction, you say, that fraction is messy, I want to get rid of the fraction, so I want to multiply by this denominator. I want to multiply both sides by the denominator, so I get y multiplied by 2x squared plus 1 equals x squared take 3. Okay, I've got rid of the fraction. What kind of questions to revise on paper 2? I could do a video on that, or you might get some help in the chat right now. I'll have a bit of a think. What kind of questions to revise on paper 2? Yeah, I mean, honestly, it's kind of random in what they can include. Obviously, it's calculator, but they always say any topic can be included in any paper. Although, if you remember the topics that were on paper 1, it's possible that they might not show up again, but that's the only clue you really get. Okay. Next, expand the brackets. So y multiplied by 2x squared plus y equals x squared take 3. Excuse me. And now I have two terms with x's in them. Two terms with x's in them. I want to combine those. How do I do that? I need to get this x squared on the left-hand side, or this term here, y 2x squared on the right-hand side. I'm going to subtract x squared. So then I have y times 2x squared, subtract x squared, and I'm going to bring that plus y over to the right-hand side, because the whole goal is to get x by itself on the left. So then I have negative 3 take y. Now, maybe you can see how I can isolate x. Can someone maybe shout out what I could do here in the next step to get x by itself? I'm not sure how long the delay is. I thought I put I thought I put low latency on, but maybe I didn't. Stream latency. Oh, it's on normal. I thought I put it on low, but it's on normal. Okay, so there might be a bit of a delay, but maybe someone will shout this out while I'm going through it. Okay, I don't want to wait too long. But the next step here is to factorize the x squared out. Again, we're trying to isolate that x squared. So if you factorize out x squared, in the brackets we're left with 2y take 1 equals negative 3 take y. I'm not sure I wrote it like that. I was getting ready to write a fraction, but I don't need to write a fraction yet. Negative 3 take y. Then I divide by 2y take 1. So I've got x squared equals negative 3y take 1. Great, yeah, now I'm seeing your replies. Then divide the other side by y, then factorize out 2 from the left-hand side. Actually, factorizing out the 2, I'm not sure about that. Oh, you said, no, never mind. Okay, yeah. So then divide by 2y take 1. And we want x, the subject, not x squared, so we still need to take a square root. So then x is going to be the square root of negative 3 take y over 2y take 1. Now, you may see this written as the square root of y plus 3 over 1 take 2y. That's equivalent. All that I've done there is multiply the numerator and denominator by negative 1. So these answers are equivalent. It doesn't actually matter which one you write. I'm just pointing that out because you might see an answer sometimes written slightly differently, and you excuse me, and you might panic and say, oh, I've done it wrong. Just be aware, sometimes you can multiply things by negative ones and you'll still get the same answer. So there you go. That was rearranging. And we're on to the next one, which is on ratios. Okay, this isn't a particularly challenging problem, but I stuck this in here because ratios is always a good topic to practice, just in case. Excuse me, having a bit of an itchy throat. It says Rosie, Matilda, and Ibrahim collect stickers. The number of stickers Rosie has, the number of stickers Matilda has, the number of stickers Ibrahim has is 4 to 7 to 15. Ibrahim has 24 more stickers than Matilda. Ibrahim has more stickers than Rosie. How many more? This is a 3-mark question. Okay, so we have Matilda to Ibrahim is 7 to 15. What is the difference in the number of parts? That's the key question here. How many more parts of the ratio does Ibrahim have? Conditional probability. Okay, I do have a probability question lined up in a minute. We can do that next, actually. So 7 to 15, that's 8 parts. And we're told that that's worth 24 stickers because the question says Ibrahim has 24 more stickers. So that means if 8 parts is 24 stickers, then 1 part is going to be 3 stickers. And Ibrahim has 11 more parts than Rosie. So 11 parts is going to be, well, actually, let's do, 11 parts is 11 times 3, which is 33 stickers. Okay. Answer is 33. If I'm going too fast, let me know. Or if there's any questions on any steps I'm going through, let me know as well. And as always, I appreciate you participating. I think we had a 2022 paper 1 mock today. Okay. Yeah. So they're using the papers from this year. That's interesting. All right. Next one. I said we're going to do probability, right? So let's do the probability question. Clear images. Confirm. Clear drawings. Okay, then let's get probability. Okay. All right. So this question is only a 3-mark question, but it is still, I would say, kind of challenging. It says Rachel has 10 sweets in a bag. 7 of the sweets are yellow. 3 of the sweets are red. Rachel takes random sweets from the bag one at a time until she gets a red sweet. She does not replace the sweets that she takes from the bag. Rachel stops as soon as she gets a red sweet. Work out the probability that Rachel takes no more than 3 sweets from the bag. Missed something there. Okay. I made a video on a similar problem to this yesterday, and I said tree diagrams will save you. Tree diagrams will save you. So if you're ever struggling to think about where to start with these types of probability questions, start with a tree diagram. Collaborative editor. I'm not sure what you mean. Okay, so we start out with our 2 branches, red and yellow. Then we could again get a red and yellow. But actually, do I need to continue with this path here if I pick a red first? I actually don't need to worry about those branches. Okay, so because the question says she takes a sweet one at a time and she stops as soon as she gets a red sweet, I can just stop here. That's where that branch ends. But if I get a yellow first, then I could get a red or a yellow. That is where that branch stops because I picked a red. And if I pick a yellow second, then again, I could pick a red or a yellow. Okay, so this is our tree diagram. It's a bit of a weird looking tree diagram because I've only got those 3 sections. Yes, so, okay, so he was meant to be joining today. I think he's had something come up, so he wasn't able to join in. But we did have it set up so he could read and write on the screen. But hopefully that works out for next week. Okay, so now we have our tree diagram. We need to fill in the probabilities. 7 of the sweets are yellow. We have 10 sweets in total, so the probability of picking yellow first is 7 out of 10. The first red is going to be 3 out of 10. If we pick a red second after a yellow, we'll have 3 reds out of 9 sweets because I've picked one out, and it says she does not replace the sweets. So after I pick a sweet out, I'll have 9 left, 3 reds, so the probability of picking a red after picking yellow is 3 out of 9. Okay, so the reason we don't need to draw this tree anymore is because that is not part of this problem. We only need to care about when she picks, basically when she picks a red sweet. So as soon as she picks a red sweet, the problem stops. There's not going to be any more continuation, right? So when you draw a tree diagram, you're you're drawing all of the possibilities of that problem. Like all of the possible continuations. So when it says she stops as soon as she gets a red sweet, there's no more continuations after that. She's picked a red sweet on the first pick. There's not going to be any more picking. Okay? So you can have these weird tree diagrams where they're kind of asymmetrical. So that's totally fine as long as you're following the rules of the question, that's all good. It can look that way sometimes. Okay, so yellow then yellow, that'll be 6 out of 9. And then if I pick a yellow, yellow then a red, I'll still have 3 red sweets and 8 sweets left over. And then if I pick yellow, 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 that'll be 5 out of 8 for that final pick. Okay, now I want the probability. What are we going to call that? What's the probability? She takes no more than 3 sweets. So probability of no more than 3 sweets. Okay, so we could pick a red first. That's just 3 out of 10. Or, we do plus when we say or, we could do a yellow then a red. So that's 7 over 10 multiplied by 3 over 9. Okay, 7 out of 10 and 3 over 9, so we multiply those. Or we could do 7 over 10 multiplied by 6 over 9 multiplied by 3 over 8. So that's the possibility of getting a yellow, yellow, then a red. And this will give us our answer, so we just need to simplify this, and that should give us our final result. There is another way to do this if anyone wants to point that out. So instead of multiplying these fractions as they are, I would suggest a shortcut here is to do some cancelling before you do the multiplications. So when you're multiplying fractions, you can do this cancelling, not when you're adding, but when multiplying. For example, I can cancel this 3 and 9, and that becomes 1 over 3. Then that multiplication becomes a lot simpler. Here, I could cancel the 6 over 9, that becomes 2 over 3. And then these 3's cancel out. And that 2 will cancel with the 2 and 8. So this becomes 7 over 10 multiplied by 1 over 4. That's much simpler than what it was before. Okay, so this becomes 3 over 10 plus 7 over 30 plus 7 over 40. It's still not really nice. We still need a common factor between 10, 30, and 40. The lowest I'm seeing is 120. I don't know if that's the best. But it's what I'm going to go with because it shouldn't be too difficult. Like, it's not worth really spending time trying to look for a lower one. So this is this will be multiplied by 12, so that's 36 over 120. Then 30 times 4 is 120, so that'll be 28 over 120. And the last one, what's that going to be? Multiplied by 3. 40 times 3 is 120. 7 times 3 is 21 over 120. Alright, and then we're adding those up. Adding those up, 50, what is this, 66? No, 56 plus 8. Yeah, 66. Or have I made a mistake? It should be fine. Oh, 6 plus 8 It's not 16, it's 14. Silly me. So that's 64 plus 21, that's 85. Okay, and that's good enough as a final answer. I said yesterday in my video, don't bother simplifying that final answer. In a non-calculator exam, if it doesn't ask you to simplify anywhere in this question, don't bother simplifying the fraction. It's just not worth it. It's not worth your time. Although someone in the chat has simplified it. So all the working up to this, yeah, all of this is fine actually. All of this is fine. This is the correct final answer, which simplifies to 17 over 24. But again, don't bother with that. Okay, how does everyone feel about that type of question? Hopefully okay. If you still feel like you need more practice on probability, check out my video again from yesterday. I went through a similar problem. What type of topic is info properties and expected frequency? Statistics, I'm guessing. Would you still get the same marks if you don't simplify? Yes, absolutely. Absolutely. So the mark scheme says, basically gives this answer and it says or equivalent, which is totally fine for 4 marks. Okay. Does anyone have any preference on what topic to do next? So I have circles, geometry question. Let's go back to this page. Clear of drawings and clear of images. Okay, so let's really step up the difficulty. Well, not completely, but oops. This is probably one of the hardest problems I have today for today's session available. How do I move that again? Oh yeah, I go here. No, I go here. Okay. So this is a geometry question. It says C is a circle with center 0, 0. L is a straight line with negative gradient. The circle C and the line L intersect at the point A and B. The coordinate of A is negative 9, 2. The x coordinate of B is 7. Find an equation of L. It's a 5-mark question. Okay, someone says they struggle. So okay, so hopefully this helps when we go through it. Alright, first thing. The first step, maybe you know what I'm going to say. If you watch any of my videos before and I've gone through these type of questions, I say this a lot, but I would strongly suggest you draw a diagram here. Strongly suggest you try to draw a diagram, even if it's a super rough sketch, right? I want a circle on the page and I want a line. A negative gradient is like this. Okay, so you want a line going through that circle. Actually, there's a ruler here somewhere. Let me use a ruler. Let me use a ruler. So we want our line and we want our circle. Oh dear, I'm messing everything up. Okay. Okay, let's get our ruler again. Apologies. Ruler again and quickly draw this again. Okay. Okay, finally. Alright, the center is at circle 0, 0. That should tell you immediately something about the equation of the circle. This is something you do need to know for GCSEs. You need to know the general form of the equation of a circle. Looks like this, where A and B is the center of the circle. Center is A, B. You might have seen that written as HK or different letters there, but the point is the same. This is the general form where these numbers in the brackets are the center. Now, if the center is at 0, 0, then the equation of the circle will look like x squared plus y squared. We don't need to worry about the brackets, okay? So this is the general form for our circle where the center is at 0, 0. We also have points where the line intersects. So they tell us some information. The coordinates of A are negative 9, 2, and the x coordinate of B is 7. So down here at B, we've got 7 something, some y coordinate. Alright, what do you think you can do with this A coordinate? If we know the form of the equation of the circle, and we know a point on the circle already, they tell us that a point on the circle is not negative 9, 2. What connection can you make there between these two pieces of information? I think once you write it down, it does help. As soon as you write the information that you've been given from the question, that can be a real help with starting these problems as well. So someone before said, sometimes I struggle to start a question, and I would suggest there, just write down the information in your own words, and that can be a good place to start sometimes. So what connection can we make? Well, what am I missing? I want to know the radius of this circle. So the way I can find the radius is to plug this point A into this equation. So I can say using A, which is negative 9, 2, I can say 9 squared, or negative 9 squared, plus 2 squared equals r squared. This will tell me what the radius is. Okay, and then I'll have a complete equation of the circle. So 9 squared is 81, plus 4 is r squared. Then r is going to be 85. R squared is going to be 85, so r is going to be the square root of 85. Okay, so I have the radius, and then the equation of the circle now becomes x squared plus y squared equals 85. Side note here, be a lot neater than this in your exam, please. Like, I'm working with limited space on the screen and I'm trying to explain at the same time, but try to be a bit neater. I did see some notes in the examiner's reports talking about how well written and neat the answers on the exams were. So I think you'll all be fine. I'm just saying, just don't take this as an example of the level of neatness to use. Okay. So now we have the equation, the full equation of the circle. And what are we looking for? We're looking for an equation for L. What do you think could help us finding this y coordinate over here? And you might not immediately see y, but hopefully your eye is just drawn to that unknown. Like, we don't know that y coordinate. It would be nice to know. But also maybe you can see if I do have that y coordinate, I can find the gradient of the line, then I'll be able to find the equation of that line, right? So I want that y coordinate of B. How can I find the y coordinate of B? Well, if I have the equation of the circle and B is a point on the circle, then I can plug in the x coordinate to give you the y coordinate. Okay, hopefully that makes sense. This is the equation of the circle. Remember, we found that by using A, getting the radius. Now I can plug in 7. So I can say, or actually, I can say when x equals 7, when x equals 7, we get 49x squared, 49, plus y squared equals 85. Then y squared equals 85, take 49. Oh, that's a nice number, isn't it? 36. And then y equals plus or minus 6. But which number will we use, the positive or the negative? This is a place where you can actually figure out what it will be if the gradient is negative. Basically, if you had a positive y coordinate, then the gradient would not be negative. So we can say y equals negative 6 in order to give you a negative gradient. Okay, now we have b. We can work out the gradient of L. So that's my next step. Gradient of L. That's y2 take y1 over x2 take x1. That's the rise over the run. So negative 6 take 2 over 7 take negative 9. Yes, the negative 6, exactly. That's negative 8 over 16, or negative a half. Okay, I'm going to erase some of this. Hopefully you don't need it anymore. This was where we found the radius. So I'm just erasing that. So we have the gradient of the line because we found the point B. Oops. Hopefully this doesn't continue. There we go, thank you. And then we can say, we can actually use the point slope form of a line. Or you could just, maybe you're used to writing it like y equals mx plus c. There's two ways to do it. You could say y equals mx plus c, or I'm going to use the point gradient form, which is y take y1 equals m times x take x1. And then you can plug the point straight in and the gradient. So then we can say, using either point, I'll use 7, negative 6. So y there is negative 6. The gradient is negative a half. And then x1 is the x coordinate of that point, so 7. Then you just simplify and that gives you the equation. So this is again the point gradient form of a straight line. Which is really useful in this situation. Okay, then if we expand those brackets out, we get negative half x plus 7 on 2. And 7 on 2 takes 6. That's like 3.5 takes 6. 3.5 takes 6. What's the difference there? Well, the difference is 2.5 and it'll be a negative because we're going less than 0. So this simplifies to y equals negative half x take 2.5 or 5 on 2. Same thing. 2.5 or 5 on 2 are the same. Okay, so final solution there. Final solution. I was going for a red tick. Negative half x take 5 on 2. Hopefully that helped for those of you that said you weren't a fan of those types of questions. Not the neatest working out ever, but hopefully the explanation made sense. Okay, I think I'll just do one more question. One more question. Then I'll just open up for Q&A if anyone has any questions. Let's do... okay, algebraic fractions, turning point, simultaneous equations or ratios. Let's clear off this page. Clear images, clear drawings. Your marks aren't for 2 weeks and yet you're still here in the live stream revising. Awesome, James. You're going to absolutely smash them. Right? Right? Can we give James some encouragement? I love that he says my mocks aren't for 2 weeks and yet he's still here in a GCSE revision live stream. That's the kind of thing that really gets me excited, you know? Okay. Let's do a turning point question. Right? These sometimes trip people up. These sometimes trip people up. And I think it's worth going over it. Just in case. Come on, James. Yes. I think it's worth going over because, you know, maybe you've forgotten how to do this. Maybe you've forgotten what it means when it says turning point. Danny, exam is tomorrow. You'll be fine. Tell me how to find the turning point here. What do I have to do? Have this equation, y equals 9 plus 18x take 3x squared. Maybe you're thinking of completing the square. And if you're not, then you know how to do it now. Yes, complete the square. Awesome. So I'm going to rewrite this equation as y equals negative 3 x squared take 6x take 3. So you notice I factorize out a negative 3. Why did I do that? Just to make it a little bit easier to use this process of completing the square. So what this means is to write the quadratic in this form. Okay, because when it's in this form, it tells you the turning point. How do we do this? We take the half the coefficient of x. Half the coefficient of x. What's half of negative 6? And also include the sign. So it's half of negative 6, not just 6. And I'll draw some big brackets. Some big brackets. X take 3, that's half of negative 6, and that goes in the brackets, and that's all squared. Then we have this negative 3 still, and the way I say this is you subtract the square of the number in the bracket. So you subtract 3 squared. Okay, because you'll notice when you expand that out, you get the same thing. You get x squared take 6x take 3. In other words, when you expand that out, you always have an extra 3 squared, which you need to subtract. Oh, so many people getting this one right. Awesome. Awesome, awesome. Okay, then we just need to simplify. So this is negative 3 multiplied by x take 3 all squared, and then negative 3 take 9 is negative 12. And then expand out the negative 3. This is negative 3 times x take 3 all squared. Negative 3 times negative 12 is positive 36. Okay, can someone tell me what the turning point will be now? And again, I know there's a little bit of a delay, but hopefully that comes through before I get to the answer. Turning point from this equation, when you have it in this form, the turning point is AB. So in this case, it's going to be 336. So the default in the brackets is negative, and the default outside of the brackets is positive. 3. Yes, you flip the inside brackets. Have I made a mistake? People are saying negative 36. Why are you saying negative 36? Let's get to the bottom of this. Yeah, exactly. These are the defaults. Positive outside of the brackets, negative inside the brackets. So that is the correct final answer, 336. Okay. Okay, I changed my answer. Yeah, okay, great. So again, the delay is getting us a little bit, but I can see your replies coming through. Thanks. Okay, well done. Hopefully that was a bit of a reminder. Maybe you're forgetting exactly what the signs were. And by the way, this negative 3 out the front doesn't affect anything. I'm kind of disappointed TeaFormula isn't here because he has a really great video on this topic talking about why that doesn't affect the turning point. But for now, it's good enough just to say if you have a number in front of the brackets, you can effectively ignore it if you're working out the turning point. Okay. All right, that's about it from me, I think, for today. I would like to keep going, but it's getting a little bit late. So I'm just going to open up. If anyone has any questions, post them in the chat, and we can talk about them a little bit. Otherwise, I'll be heading off. And if anyone has their exam tomorrow morning, good luck. I wish you all the best. I'm sure you'll do very, very well. And I hope you walk in there confident. And thanks, great stream. Thank you, HA. Make sure you go over to TeaFormula's channel. Leave a comment on his latest video saying, why weren't you at the live stream or something. Yeah, I hope you walk into your exam with your head held high, and if you sit down and you start feeling nervous, you start feeling anxious, just take deep breaths and try to relax, because there's nothing worse than trying to work on exam questions when you've got that anxiety hanging over you. Abdullah, how useful is A-level further maths? Maths explain merch. Wow. Actually, there might be an update soon. I don't think it'll be merch. It'll be more revision related content. So A-level further maths, personally, I find that content very interesting and useful. If you want to go into any kind of science, engineering, whatever in university, then I would highly suggest doing further maths. It depends what you want to do after A-levels. Abdullah. Do you think November exam will be harder than the summer exam this year? Usually they are. Just looking at the pattern from the last few years, not a lot harder, but for some reason they make them a little bit harder. I'm not sure why. Can you look at the advanced information for tomorrow at Excel paper 1 and point out the hardest topics? I don't need it for university, but it looks fun. If you say it looks fun, then I would suggest doing it. I mean, there's a lot of content in there that is not in A-level mathematics that is interesting, like imaginary numbers. You learn about those, you learn about complex numbers. That's something you don't do in A-level mathematics. So some really good stuff in there that I think is worth learning. Advanced information. Add Excel. Yeah, oh, they do have it for. I haven't read this yet, so apologies. I should have gone over this. Da, da, da. Do you think it would be too much with chemistry and biology and maths? Depends. I mean, those subjects, well, physics goes well with maths. Chemistry and biology don't really have too much synergy, but yeah, I'm not sure. Just depends on you, I think, for that type of question. I mean, personally, I didn't study biology. I was more a physics person. Found that more interesting. But some of my friends studied physics, chemistry, biology, and maths, so it's possible. And I think there's still some synergy there. Like, it's very common to do that kind of science. What's it called? Overview or whatever. Next week, I think, will be the next stream. Alright, so I think I'll call it there. Thanks for joining in, guys. Sorry I couldn't give much information about that advanced information document. I'm just looking at it now for November 2022. But yeah, I don't have too much to contribute about that, sorry. Well, actually, a lot of the content we covered today. So they had manipulation, algebra manipulation, algebraic fractions, simplification, we did that, ratio, probability, combined independent events, we did that. So a lot of the content on there we actually covered today. Okay. Alright, if you like these live streams, please join in next week as well. I will be live either, probably Tuesday. Usually it's Tuesday. Today was Monday because there's an exam tomorrow morning. Okay. Again, thanks for tuning in. If you're watching this video after the fact, hopefully you found that useful. Before you guys leave, I'd really appreciate if you left a like on the video. It really helps out. And subscribe if you want to see more content from Maths Explained, which is me. So yeah, thank you so much. Good to see you again. All right, see you next time. Bye.